Okay, the next practice problem is on the list. There's 1.53 and 1.54. I'm going to do 1.54 just because those are the only two that are similar. And it says to write each number in scientific notation. Well, all the time, anytime you see scientific notation, you want your brain to be triggered that you're going to be writing the number as some number times 10 to the something. So scientific notation, let it tell you you're writing that number as a number times 10 raised to a power. Okay. So the first hint that I want to give you that you've probably learned in class is that when we are moving our decimal to the right, as in A, we have 0.0042. So we're going to move our decimal, as you were taught in class. We're going to move it 1, 2, 3, 4 times to the right. Anytime you move a decimal to the right, let it remind you that you're going to have a negative exponent. And I actually moved that too far to the right, so let's do this. We're going to move it 1, 2, 3. So remember in class we learned that we move the decimal all the way past all the zeros to the first whole number. So our first whole number is going to be 4. So we're going to put the decimal in between the 4 and the 2. So I'll just write it right now, 4.2. That's our number. So we're going to do some number times 10 to the exponent, right? And that exponent, when we go to the right, so when we go to the right, our exponent is going to be negative. Exponent is negative. So how many did we go to the right? So we start where our decimal was and we count. We went 1, 2, 3 to the right. So this number is going to be negative because we went to the right, 3. So our answer is 4.2 times 10 to the negative 3. Okay, you look at a number like 310 and you're like, can you do scientific notation? You absolutely can. What I like to do is draw in my decimal first. Where is our decimal in this whole number? It's right here. We know that there's like a list of zeros after that, or can be. So this is where our decimal is. That's where we're going to start. And this time we're going to the left. So remember, when we go to the right, our exponent is negative. When we go to the left, it's going to be positive. So we go until there's one whole number before our decimal. So we're going to go 1, 2 to the left. And that gives us 3.1 times, how many times did we go to the left? We went 2 times. And remember, we went to the left. So to the left, exponent is positive. So to the left, exponent is positive. Okay, the next one is a really big number, 890, million. So first of all, I want you to think in your head, where is the decimal? And are you going to be going left or right when we move our decimal? So here's the decimal at the end of the number, and we're moving left. So is our exponent going to be positive or negative? Since we're moving left, our exponent's going to be positive. So I know that my exponent, before I even draw my arrows, or my number is going to be 8.9. I can just look at that right now and say 8.9 times 10 to the something. Now we just need to count how many times we moved our decimal. 1, 2, 3, 4, 5, 6, 7, 8. So that's 8.9 times 10 to the 8th. Okay, our last one. Are we moving our decimal to the right or to the left? If we're moving it to the right, our exponent is negative. Another way you can think of this is that negative numbers are like smaller numbers, right? And these decimals are smaller numbers. So sometimes it's easier to memorize going to the right will give me a negative exponent. Or you can say, this is a really small number, I'm going to have a negative exponent. Or it's a decimal, so it's a small number, so I'm going to have a negative exponent. So I know that my number is going to be 5.6. Now we just need to find out what our exponent is, and we know it's negative because we're going to the right. So we go to the right 1, 2, 3, 4, 5, 6, 7, 8 times. So our scientific notation is 5.6 times 10 to the negative 8.